Well, hello everybody. Here's what you missed the other day. These are my plans for section 1-4, day 4 of my chapter 1. But here's what you missed. What I did is I answered any questions that they might have had over section 1.3, those literal equations. You have the answers coming up. Look those over and make sure you know what you're doing, because we will be taking a quiz. So you're behind a quiz also if you're watching this video. And then I covered absolute value equations. Should be reviewed, but I'm going to treat it like you've never seen it before. And then imagine this. You'll have an assignment. So I'm going to just click through these answers. I'm not going to pause and give you time to grade your worksheet, because what you can do is start the video. You can also hit pause on it and make sure your answers are okay. So there's the answers on 1 through 8. There's the answers on 9 through 16. Really pay good attention to these literal equations, 11 through 16, because those are tough for some students. And then 17 through 22. So there's what we got going so far. I'll see if I can move that down a little bit so you can see number 22 better. Okay. And then that brings it home. Properties are fair game and sets of numbers, so make sure that you understand that. If you don't understand, make sure you ask me about it so I can get you straightened out on that. Okay? And then I answered a few questions for the class, and then we did take a quiz. This quiz will take about 15 to 20 minutes. So plan accordingly for that. We need to get that made up. And then after the quiz, it's kind of a shorter lesson. I covered absolute values. So here we go. These are your class examples, so hopefully you got your day 4 class example sheet right in front of you. You have been taught absolute value just means make it positive. There's some truth to that, but not very good truth. Absolute value really means, I'll say this 3 or 4 times, it really means distance from 0 is what it really means. It's kind of like, since I coach cross country, if I send the guys for a 3-mile run this way, and I sent the girls out for a 3-mile run this way, they still both ran 3 miles. One of them didn't run positive 3 miles, and the other one didn't run negative 3 miles. When we deal with absolute values and you see that negative sign, it really just means we're going to the left. So this says start at 0 and go negative 7.2 units, so go to the left, 7.2. How far would you have traveled? 7.2. Number 2, I got negative 7 plus 10. If I simplify what's inside the absolute values, I get the absolute value of 3. And the absolute value of 3 is 3. On my number 3, if I simplify negative 11 minus 8 first, I'm going to get the absolute value of negative 19. The absolute value of negative 19 is positive 19. So pretty easy so far. Now, number 4, there's a negative sign hiding out here. So I'm going to have a negative. Now I'm going to simplify the 10 minus 5. So 10 minus 5 is 5. So I have the opposite of the absolute value of 5. Well, the absolute value of 5 is 5. But I need the opposite of it. So negative 5. So you say, but Mr. Harris, I thought absolute values couldn't be negative. You're 100% right. But since I put this sign out there, I need it to be the opposite of whatever you get. So here's my number 5 and number 6, a little bit of calculator work. What I need you to do is this. I've got 8.4 minus the absolute value of. I'm going to plug negative 7.5 right there. So I'm going to have 2 times negative 7.5 plus 5. So what you'll do is in your calculator, you're going to go 2 times negative 7.5 plus 5, and you're going to get the absolute value of 10. Well, here's what I really have now. I have 8.4 minus the absolute value of 10 is 10. 8.4 minus 10 is negative 1.6. So don't try to type all this in your calculator. Simplify the absolute value part first, and then go get the answer. Here's my number 6. I've got the absolute value of 5 times negative 2 plus 3 minus 2 1/2. Well, you're going to run this part through your calculator first. 5 times negative 2 plus 3 becomes the absolute value of negative 7 minus 2 and 1/2. Absolute value of negative 7 is 7. So I got 7 minus 2 1/2. So in your calculator, you can go 7 minus 2, fraction key 1, fraction key 2, and you're going to get an answer of 4 and 1/2. You might have got 4.5. You might have got 9/2. All of those are great answers. Okay. So drop down to number 7. I got to switch ink color just a little bit for you so I can show you what I mean. Absolute value, like I said earlier, just means distance from 0. This one is not on your sheet, not on yours. So the absolute value of some number equal 5, here's what it means. I want you to start at 0. Go 5 units to the right. Go 5 units to the left. And tell me what numbers you end up at. Well, when you went to the right, you ended up at 5. And when you went to the left, you ended up at negative 5. So whenever you see absolute value, there's usually going to be 2 answers. Algebra 2 is full of different notation. So when we list answers in absolute values, we're going to do it this way. You'll have those braces. I call them cool parentheses, but they're really called a brace. And then you list your numbers in there. I don't care if you put 5 comma negative 5 or negative 5 comma 5. I traditionally put the little number on the left. This tells the world that these are 2 answers. The brace here tells them that a set of numbers is coming your way. They just happen to be the answer to that absolute value. So here goes your number 7. Here's what it means, and you'll get these in your head. It means I want you to start at 0. When we get done, I want you to be at 8 and negative 8. So here's your job. You got to go find me 2 times some number is going to put me at 8. Well, what's that number? The number is going to be 4. Now, 2 times some number is going to put me 8 units to the left. So 2 times what number is negative 8? That number is going to be negative 4. Well, here's my 2 answers then. As a solution set, my answers are negative 4 and 4. So, Mr. Harris, the answers will always be the same, just opposites? The answer to that question is no. The next one's going to be a little bit different. So here's your number 8. And then I'll talk more mathematically about it. Some number plus 3 is going to put you 5 units away from 0. Well, you're going to start at 0. When you're done, 1, 2, 3, 4, 5, I want you sitting right there. And I want you sitting right there when we're all done. Well, here's got to be your thinking. Some number plus 3 is going to set me at 5. Going to put me right there at 5. What's that number? That number is 2. Coming over here, x plus 3, some number plus 3 is going to put me 5 units to the left. Well, that number is going to be negative 8. Because negative 8 plus 3 is negative 5. My 2 answers then, there's my cool parenthesis called a brace, negative 8 comma 2. Okay. Hey, mathematically, guys, here's what we're going to do. Once you get the absolute value by itself, we're going to set it equal to this number and its opposite. So here's your number 9. Some number minus 8 is going to put me 12 units away from 0. So when we're done, you're going to be sitting at 12 and negative 12. So my thinking is some number minus 8 is going to put me 12 units to the right of 0. Some number minus 8 is going to put me at 12 units to the left of 0. Hey, now just solve these 2 equations. Add 8 to both sides. So I got x equal 20. Add 8 there. Add 8 there. My other answer is negative 4. Let me see if this works now. I'm going to sub 20 right there. 20 minus 8 is 12. The absolute value of 12 is 12. So that's a good answer. Negative 4 minus 8 is negative 12, but the absolute value of negative 12 is 12. So both of those answers work. So parenthesis, negative 4, comma, 20. Ms. Harris, can we use a parenthesis to put those in? Nope, because that means something else. Can we use a bracket? Nope, because that means something else. It's got to be these parentheses. Hey, and trust me, guys, I've seen some ugly parentheses. Just do your best. It's just kind of a little swoop. Okay, here's number 10. And then I gave you on your class example sheet, I gave you the steps to solve these. Set the expression within the absolute value equal to the number and equal to its opposite. And this only works if the absolute value part is on one side by itself. So I've got the absolute value on one side all by itself. Well, what am I going to do? I'm going to say 3x minus 2 can be 10 units to the right of 0, or 3x minus 2 can be 10 units to the left of 0. So guys, all I'm doing is I'm setting that equal to that, and I'm setting that equal to its opposite. Now we're just going to solve this. I'm going to add 2 to both sides and get 12. I'm going to divide both sides by 3 and get 4. So there's one of my answers. Over here, I'm going to add 2 to both sides and get negative 8. I'm going to divide both sides by 3. And then I'm not going to touch my calculator. I'm going to leave my answer as negative 8 over 3. Listed as a solution set, I've got negative 8/3 and 4. So there's my answer. Let me keep on going on it. Here's your number 11, I hope. Here goes your number 11. I've got the absolute value of 5x plus 7 equal 42. The absolute value is on one side all by itself. So I just need to go 5x plus 7 equal 42, or 5x plus 7 equal negative 42. 42 units to the right, 42 units to the left. Now solve each of these. I'm going to subtract 7 and get 35. I'm going to divide both sides by 5 and get 7. On this side, I'm going to subtract 7 and get negative 49. I'm going to divide both sides by 5 and get either 49/5 or negative 9.8. Whichever way you like your answer. Listed as a solution set, it's going to be negative 49/5 or negative 9.8. The other answer is going to be 7. And then we got it. But guys, this only works if the absolute value is by itself. If it's not by itself, we have to get it by itself. So thus, your number 12. On your number 12, I've got to get the absolute value part by itself. So I'm going to box this in. Don't do this to yours because I got an eraser that will erase all this. I've got to get that box by itself. So pretend that you have 3x minus 11 equal 19. Well, that's going to be my first step. I'm going to need to add 11 to both sides. So I would have 3x equal 30. Well, that's what I'm going to do over here. I'm going to add 11 so that on this side I now have a 30. Then I would have to divide both sides by 3 and get 10. That's what I got to do over here. Then I'm going to divide by 3. Now the absolute value is by itself. So I now have a 10 right there. And on this side I have 2x minus 1, absolute value. Okay, so let me run through that again. You can't distribute into the absolute value. And the reason we don't want to, sometimes it works, sometimes it doesn't work. If it's a positive, it'll come out okay. If it's negative, it'll mess everything up. So do any addition or subtraction first. That's where I got 30. And then divide by that number. That's where I got 10. Now we're ready. Now I'm going to go 2x minus 1 equal 10. And I'm going to go 2x minus 1 equal negative 10. Add 1 is 11. Divide by 2, so 11 halves, or 5.5. add 1 over here and get negative 9. Divide both sides by 2. My other answer is negative 9 over 2, or negative 4.5. I don't care which one you use. Listed as a solution set, negative 9 halves, comma, 11 halves. Okay? Then I just got a few more. Here's your number 13. My first question to you, is the absolute value by itself? And the answer is no. So there's nothing to add or subtract, but I need to divide both sides by negative 3. So then I would have the absolute value of 5x plus 1 equal positive 8. Now the absolute value is by itself, so we're ready to go. 5x plus 1 equal 8. 5x plus 1 equal 8 units to the left, so negative 8. I'm going to minus 1 and get 7. Then I'm going to divide both sides by 5. Notice, guys, I don't even touch my calculator. I leave it as fractions. If you wanted to call that 1.4, I'm okay with that. On this side, I'm going to subtract 1 and get negative 9. Divide both sides by 5, so I got negative 9/5. As a solution set, negative 9/5, comma, 7/5. Like I said, you could have these numbers flip-flop. I like the little number on the left. You'll see why as we do more and more and more. Here's my number 14. I'm going to ask you, is the absolute value by itself? Hopefully you'll say no. There's nothing to add or subtract, but I do need to divide by negative 2. So I now have the absolute value of 3x minus 4 equal negative 9. Hey, I'm going to stop right there for just a second. This is a nice problem. There's no number in the whole wide world that I can take the absolute value of and get a negative 9. So if you're ever solving a problem, after you get the absolute value by itself, and you get a negative number right here, you need to smile because there's no answers. So the empty set sign there means there's no solution. Okay? Now if you look back on your number 13, I had a negative number. But it became positive when I divided both sides by negative 3. So that was okay. This became negative though, so no answer. Okay? And then I just got a few more. When there's a variable on both sides, the steps are the same, but we have to watch out for what's called extraneous solutions. I've got those written right down there. An extraneous solution means you've done the work and got the answer, but it may not fit into the problem. So here's the steps, just like what we've been doing. I'm going to go x plus 10 equal 4x minus 8. My other answer is x plus 10 equal the opposite of this. Well, the opposite of positive 4x is negative 4x. The opposite of negative 8 is positive 8. So there's my two equations. Now we just solve it. I'm going to minus x from both sides. So I've got 10 equal 3x minus 8. I'm going to add 8 to this side and get 18 equal 3x. So x is going to be 18 divided by 3, which is 6. Over here, I'm going to add 4x. The reason I wanted to do that, guys, is I knew it would be positive if I moved that over here. So I now have 5x plus 10 equal 8. I'm going to subtract 10 from both sides. So I have 5x equal negative 2. I'm going to divide both sides by 5, and I'm going to get another answer of negative 2/5. Hey, now I got to pause here for just a second. And you only have to do this when there's a variable on both sides. I need to make sure both of these answers work. So I'm going to plug a 6 right there for a second. Well, if I do that, 4 times 6 minus 8 is some positive number. Since that gives me a positive number over here, it works. Really, it becomes 24 minus 8 is 16. Plug a 6 right there, I got 16. The absolute value of 16 is 16, so this answer worked. But I need to try negative 2/5 also. So check out what happens. If I plug negative 2/5 right here, I got to go negative 2/5 plus 10. Well, if I do that, I'm going to get 48 divided by 5, 48/5. If I plug negative 2/5 right here, though, I'm going to get negative 8/5 minus 8, which is some negative number. What negative number is it? Negative 48/5. This side's always going to be positive, but since I plugged in negative 2/5 and got a negative number, I cannot use that number. Called an extraneous solution. It means I've done all the work to get the answer, I just don't get to use it. So the only number that goes in our parentheses, our brace there, is at 6. Okay. Hang with me, I just got 2 more. Here's your number 16. The same setup. When I set this up, guys, I got to go 3x plus 14 equal negative 2x. And then I've got to go 3x plus 14 equal the opposite of that. Well, the opposite of negative 2x is positive 2x. Hey, now let's solve it. I'm going to minus 3x from both sides. So I have 14 equal negative 5x. Divide both sides by negative 5, so I got negative 14 over 5. Pause for 1 second. If I plug a negative number right there, I'm going to have a negative times a negative, which is a positive. That means this answer is okay to use because it gave me a positive number over here. Let's try this one, though. Let me minus 3x from both sides. So I've got 14 equal negative x. Divide both sides by negative 1 and get negative 14. Let me see if I get to keep it. If I plug negative 14 right there, a negative times a negative is a positive, so I get to keep that answer also. Even though they were negative, they worked. So when I list it, I got negative 14 and negative 14/5. And then my last one. There's a variable on both sides, so we got to check for those extraneous solutions. So when I set this up, I've got 2x plus 9 equal 5x minus 6. And I also have 2x plus 9 equal negative 5x plus 6. The opposite of 5 was negative 5. The opposite of negative 6 was positive 6. Now solve it. So I'm going to go ahead and get the x's on the right on this one. So I got 9 equal 3x minus 6. I'm going to add 6 and get 15. Divided by 3, I'm going to get 5. I'm going to peek at it real fast. If I plug 5 right there, I'm going to get 25 minus 6 is 19. And it's positive, so that's good. 2 times 5 is 10, plus 9 is 19. My numbers match up. I know that's a very good answer. Now let me try this one. I'm going to add 5x to both sides. So I've got 7x plus 9 equal 6. I'm going to minus 9 from both sides. So I got 7x equal negative 3. X is going to be negative 3/7. So here goes. If I plug negative 3/7 right here, I'm going to get negative 15/7 minus 6, which I know is some negative number. Since that's going to give me a negative number over here, I don't get to use that number. The only number I can use is the 5. So that's the lesson in a nutshell. So we took a quiz, we did these absolute value equations, watch it when there's a variable on each side, and of course we had a worksheet. It's worksheet day 4. If you haven't picked it up, it's in the folder. I'm hoping that you had your notes in front of you before you did this video. So good luck.